Okay. But this is not an instruction video, it's just me celebrating my 10 years anniversary of learning physics. So if you want to learn anything related to a specific topic, click out. I'm just going to talk about what I've done for the last 10 years related to physics, what I've learned, and yeah, pretty much the journey, the review of journey. 2010 I started learning physics from middle school. So basically what we're doing is like pulleys, some circuits for middle school, and high school we do some conservation of momentum, conservation of kinetic energy, and some capacitor, resistor, inductor, stuff like that. So from the beginning, I was actually very confused on most of the concept, like how to use like I equals U over V over R, stuff like that. It doesn't make sense. It doesn't click at the beginning. Of course, like no one does. I don't think, at least not me. So what happened is, since the problems are pretty similar, so the method of solving it is almost the same. So turning from bad to good, what it takes pretty much is only repetition, and that's exactly what I did. Just look at this problem, solve it. If you don't understand it, solve again. If you still don't understand it, solve it again. And after tens of times, you'll understand. It just takes some dedication. That's all you need, honestly. So at the time, we learned like classical mechanics and electrostatic from like the first 4 years, middle school and high school. So my mindset is just like confused, like what is going on, like why that's the case, like why this formula just pop out of nowhere for no reasons, even though it works well, like matchless experiment, but why? What's the purpose? And at the same time, I was curious. Like, for instance, one of the things that was very curious in middle school is like the strict definition of fluid and solid. I'm talking about, not like look at like something solid is solid, something like fluid is fluid. No, I'm talking about molecularly, in terms of molecule, like the distance or the molecular structure of it to determine or define whether it is solid or fluid. So yeah, the first 4 years come by. I start my college 2014, and I started to finally know some real physics. So here's some diagram from classical mechanics 2. We learned gyro motion. Basically, imagine a top or a football. It just rotate, and if you do a spiral, if it's really good, then it barely do this tumbling motion. But if it's really bad, it will tumble like this, like crazy. But if it's really good, then it tumble really slowly. Really small angle, like this angle. But it still has. I mean, there's no way you can throw a perfect spiral, like on the axis. What I mean is, so this is not trivial to solve, and this is my first research in the college. This is a high-V ion collision, lead on lead, and the thing I study specifically is photon jet back-to-back collision that to study the quark gluon plasma. Don't ask me the detail. I don't know that either. So what I'm doing is just doing simulation and do a statistical analysis on those on data I put out, and comparing with the experiment in CERN. So at that time, the way of learning changed, because it's not a similar problem anymore. So the same method doesn't work. what I need to do is I have a different, almost completely different problem every time. But fortunately, in college we are given a general method. So basically, that method can apply to any scenarios. It doesn't need very rigorous mathematical skills and tools. So the different problem gave me a different way of learning. So I learned from the book or videos. You know, thankfully in college, there's the things that I learned has a substantial amount of material online in the form of video. For instance, MIT open course and Stanford, stuff like that, and I read the book, watch the video, and find the concept, try to understand it. I mean, most of the time the concept is being explained in a relatively complex manner, and except the professor and instructor are or the writer are very good at explaining things, which hardly come across, but I'm fortunate enough to come across one of the best teacher during my college, which I feel very fortunate. So the concept will need to be internalized, at least for me. I need to simplify it in the sense that, for instance, something very complex like a photon jet collision, you can just thinking about one part, two have same momentum, one just goes straight through, like touch nothing because this photon doesn't interact with quark gluon plasma, and the jet, it's just like a spray of paint going through a pool of water. It will be dispersed and quenched. That's the name. The quenched over the liquid. Or the quark gluon over the plasma. So those complex concept, if you want to calculate it, of course you need some very sophisticated mathematical calculation. But after simplifying it using various daily life model that you can understand, then it's actually very easy to be understood. After that, you learn all of the information, and you need to the best way to learn for final and midterm is just to summarize all of the simplified models to make you know to connect all the dots and see the class as a whole instead of chapter by chapter. Those chapters are interconnected. The only time you can review and reflect is the exam most of the time. Unfortunately, that's how a college kid works. So we need to summarize it. Other time, I learned classical mechanics, all four courses that everybody learned in physics: classical mechanics, thermodynamics, quantum mechanics, electrodynamic. And for other classes I took like hydrodynamic and particle physics. So during the research on this, and then one research on building polarimeter for high energy experiment, I learned 3D modeling, circuit board design, and for this simulation I learned coding and also mathematical modeling. So at that time, how I feel is I'm fascinated by the beauty of the physics. It's simple. Let me explain the future, so don't jump on it. And it's symmetric. Let me explain the symmetry first. So most of the time we're dealing with cylindrically symmetric scenarios, spherically symmetric scenarios. It just reduces the degree of freedom and just make it so easy, relatively easy to solve. And on if you look at your daily life, a lot of things are symmetric. Like for instance, this is cylindrically symmetric if you only look at the top, but it has more complication, and thus adds to that's two cylindrical symmetric movement. So one is this, another is this. Anyway, this is this could be simplified. Instead of solving a multi-dimensional movement that need very, very complicated mathematical equations. Or another symmetric things that everyone use is Maxwell's equation. If we add a magnetic monopole in it, and the Maxwell's equation will be strictly symmetric. And for a lot of equations are actually symmetric. What I mean by symmetric is like if you interchange E and B, electric field and magnetic field, you will actually get the same exact equation, and not in terms of special relativity. It actually is the case. It is interchangeable once you're moving in the moving frame, in a sense. And I kind of forgot the details. Anyway, that's how I remembered it, and that's very pretty or elegant for me at least. For simple, it's not simple that I mean is easy to solve or easy to learn. And what I mean by simple is, at the end of the day, the complex motion of motion or complex phenomenon that you saw or see in daily lives can be written in a relatively simple and elegant equations, which is tremendous. Basically, if you have any classical, like any classical object, like just like big book, you throw it, and it's just the page flopping around and it self-rotate and all those complex motion, they will be very hard to solve. There's no deny to that, but it can be simply calculated by Newtonian mechanics, which is one equation. You just need a whole lot of, you just need to dissect this into different components and solve it, but in the end, the law governing it is very simple. It's just one equation. And it's almost the same for all the other fundamental forces, but let's not get into the strong force and weak force. Let's shovel this under the carpet. Anyway, but the electromagnetic and classical mechanics are very, very elegant. Quantum mechanics as well. So this simplicity gives me a conceptual understanding, which is essential. Like for instance, in Lagrangian mechanics, we can think. The reason why, like, we can not thinking like, oh, just F equals ma. That's it. We can actually thinking that the particles or the object has a tendency to have least action. What I mean by that is that the particle, for instance, have the most probability to go through the path that required minimal effort, meaning it will go through the place that have the lowest potential, or stuff like that, or in classical way. In classical way, you can thinking that if you drop water through a path, the water will always go through the paths that require the minimal minimal effort, or goes through the lowest point of every single path it goes through. That's actually governed by a very elegant equation called Lagrangian equation. Same for quantum mechanics. You can use a path integral. That's basically telling you that for particle it goes through has the highest possibility to go through the least action motion, which agree with classical mechanics, because quantum mechanics can be implemented to classical mechanics, but why bother? You're just solving harder equations where you can use this much simpler models. Anyway, after 4 years I graduated, of course, I started my graduate school. So I started teaching and doing research. That's one of the turbulence, which is Tierney mode, and that's the thing that studies this tokamak, and that's basically a particle moving in the on one rational surface. And then here, that's me in front of my computer. I'm dying because basically just coding all day, Monday through Sunday. I mean, it's not I'm forced to do work Monday through Sunday. It's more like I enjoy doing it. But at the time, so far, only 2 years in this. 2 years in this program. So yeah, I learned nonlinear dynamic, plasma physics. Of course, I learned classical thermal, quantum, and electrodynamic once again, but almost a similar material, just taught in the graduate school again, just to make sure that everybody in the school are on the same page, pretty much. And I also learned, sorry, let's just leave it. So this gave us a different, give me a different type of problem. We have new problem, like this problem is known and have no solutions, you can ask around, but this now, doing research, you are having new problem and you have to use a new or improved method to solve it. So what I do is just reading paper or book. Unfortunately, the video from now on is just not available anymore, because it's just the topic is so specific that nobody in their right mind will make a video of it, because there's no profit. But there's also not enough people in the world and so that there's some people gonna be willing to post stuff like that. It stands now, I'm not gonna post everything that I think I know sufficient enough. That's why I actually started this channel. So I read the paper, the book, and internalize the concept, simplify it as well, and have an idea. Basically, read and talk to colleagues, read papers, read books, and have the idea. Then I will start to use the idea to test certain base case, like well-known cases, and compare it with the known result, and if it works, and say, okay, that idea might works well, so let's use it, implement it to other cases, and it works well, great. Here is new foundings or new method or new whatever, new theory. And during that time, I have to speak in front of a lot of people. For instance, my qualifier, my PhD candidacy qualifier, and so basically the skill that I already obtained here are enforced. Of course, the coding and mathematical modeling and stuff. But I also obtained the public speech and problem solving. Basically, this new problem, new method, scenario forced me to jump out of my comfort zone. Basically, I know the answer, and there's no consequences. I don't know the answer, there will be consequences. It in a way boost up, basically humbled me in the first place. Like, I see my colleagues are just so accomplished and so talented. Not talented, is more like more hardworking or talented. That I think I admire them at the same time, in a way jealous, but humbled by how good they are, and then inspired by how good they are, that I want to work towards them to be as good as they are someday in the future. So after 2 years now, 10 years of learning physics, that's a long time, man. That's I would dare to say that if you put any effort to something for 10 years, at least you will see some level of improvement. And I'm sure I see some improvement over the 10 years of learning physics. I mean, I can now self-obsessively say that I do it professionally, because I get paid for that. So what I feel after this 10 years is more like a real journey that from doubting myself, from confused, doubting myself, and through hard work, I start to feel okay about the concept, and being actually fascinated and curious about the concept, and but in the doing physics as a major, and doing the research, and learning a whole set of skills that prepare me for the graduate school. And I have the privilege to teach the things that I've learned to other students, and doing the research that I'm doing right now that could potentially change the world. This is, fusion, thermonuclear fusion could be possible in, I don't know, 30 years. That's a running joke if you don't know. Fusion is always 30 years away. Let's hope this is the last 30 years away. So I'm humbled by the brilliant colleague that I have, and inspired by them, and I setting the goal that I will be like them one day. So I would say that the doubt that previously unfortunately casted by my families and casted by myself, now almost all gone, thankfully, because I find that being a physicist is not just learning physics. It's more like martial art. It's not just like you learn it to defend yourself. It also gives you very, very strong mindset that after you through hard work you can accomplish a lot of things. And also the physics is not just physics itself. You can apply it to engineering, circuit board design, 3D modeling, like those old engineers do, because I was in the experimental group. And you can also do mathematical modeling, which can be used almost, I would say, anywhere on from insurance calculations, from insurance to like trading, to any type of things can be quantified. You can use mathematical modeling. So for a lot of people that is unsure about learning physics, is that you don't need to worry about it. After you graduated, you have more than enough skills to make you set for your future. That in terms of the skill set that you obtain through either research or the class that you're taking. So I can't really talk all day. Let's just stop it here. After 10 years, I'm blessed. I'm very, very happy that I am who I am right now, because of course the people surrounding me, my family, my friends, my mentors, but also because the fortunate and the luck, in the sense that I come across the things that I actually love. And also I have to say that I'm glad that I convinced my family, and also after that I'm glad that my family fully support me, regardless of how much hardship I've gone through over this. And also I'm extremely blessed by the mentor I encountered throughout the whole journey, middle school, high school, college, and the graduate school. This is more, is almost surreal that I have in almost all the mentors that I encountered and teachers I encountered are just very good at teaching, very good at explaining concept. I'm very easygoing, which I learned a lot from. And aside from physics, I would like to thank my taekwondo coach in college. Actually, is I learned. That's the first time I actually started to learn how to really teach students, and this translates really well towards my TA teacher assistant work in the graduate school, and also the philosophy of a martial art, in a sense, keep me going, because pretty much the same time I started learning physics, I started learning taekwondo. It just gives you a warrior mindset. You have to keep going. If you're not good now, you will be good enough if you work hard enough, and just never give up. I guess I'll just stop it here. That will be too long. Right, thank you.